This song is dedicated on this fun Friday to all the science teachers out there in the classroom or the Zoom, especially those zany Zygnerskis with their kitchen chemistry. This is Notorious MC, Mme Curie, coming at you live from my laboratory. It was not a dream, March 13th, 2020, the day we put the beakers down and started quarantine. Periodic table hanging on the wall, but every Friday was fun and we had a ball. Testing acids and bases with cabbage juice, playing with titrations fast and loose, balancing equations, electron configuration, our bonds covalent without explanation. COVID-19 can't combust our reaction. Science will give you some satisfaction. We learned entropy is a lack of predictability, and you'll always remember stoichiometry. And if you don't know, use sig figs, you dig? Mme Curie, out. Have a safe and wonderful summer.
To another fabulous Friday Fun Day. I'm your host, Mrs. Zygnerski, and welcome to my kitchen and later to my backyard, but more about that in a minute. Can you believe that this is our 10th episode already? I can't believe it. And it is going to be the last one of this season, so we hope you enjoyed this episode. So in this one, we're going to go over, again, reactions. There are 5 basic type of reactions. There are synthesis reactions, where 2 elements or 2 compounds come together and make one. Then there's decomposition. Sounds just like the name implies, which is one thing breaks down into 2. It decomposes. Then there's something called single replacement reactions, when an element replaces another, usually a cation, in a compound to form another element and a new compound. Then there's the double replacement reactions. Double replacement mean that there are 2 compounds where the cation switch places, kind of like a do-si-do, and create 2 new compounds. Double replacement reactions we saw with the acid and bases. There's another type that's the acid and carbonate. That's also a double replacement and a decomposition. So in this one, we're going to focus on single replacement reactions. So with single replacement reactions, we're going to do something that we typically do in a chemistry lab. So for my dudes, you probably already did a little part of this, but trying to expand on it. So for this experiment, when we go outside, we're going to need like copper. Okay, so I have copper sheet, but I'm going to be using this copper wire. I'm also going to be using a watch plate, plastic. I have some magnesium ribbon. Root killer. Root killer is actually copper sulfate pentahydrate. Pentahydrate just means that there's 5 water molecules that are attached to the copper sulfate. All right. I only have the salt out just in case we need it. Sometimes we do. And soda can, aluminum foil. But of course, with safety, we're going to need goggles and our safety gloves. Before we begin, I need to do a wardrobe change. I know you guys like this one. That's more like it. So, what we're going to do, I'm not going to do this inside. We are going to take this experiment outside. Now, if you are to choose to do any of this ever at home, please, in front with your parents or some guardian, somebody that you can trust, and Do not do it inside. Do not mix the chemicals. You don't want to take a chance of ingesting it. As I said, you're using root killer. You don't need to kill your insides with that. And just common sense. I appreciate that. All right, so we're going to go outside. Ready? All right, so here's my little makeshift lab back here. What I'm going to do, I actually have a copper chloride solution. This is typically what we use in the lab, but we're also going to use the root killer. And when you guys see this, some of you might recognize the telltale shape of the crystals for copper sulfate. So I'm just going to put a little bit in there and just kind of like dilute it up with just, this is tap water. Ideally, you should have like deionized water. It's a fancy way of saying that there's no ions in it and it was just boiled off and condensed. So we're just going to let that just happen and soak in. All right, in the meantime, while that is starting to dissolve, all right, I'm going to take some of the magnesium and I'm going to put a little bit in here and a little bit in here. All right. This is why we got pockets. I'm going to put a little piece of the aluminum in there. A little piece in here. And what I'm going to say is this is why when we do anything with copper compounds in the lab and we're using the metal spatulas, this is why Mrs. Z gets a little bit perturbed when you guys just leave it in your in the container, because there are certain metals that are in there. And hey, stay. What's going to happen is that people are like, oh, it looked like it rusted. It didn't rust. There's a difference between when it rusts and not. All right, what I'm going to do first, while this is still trying to well, actually, I'm only going to put the copper in the one, not in the other. Because the copper chloride, you'll see why. I don't know if it's dissolved or not, but I'm going to see if this is enough for it to happen. And if worse comes to worse, I will always add more. All right, so we got to see evidence of a chemical change. Evidence of a chemical change can't be that a gas is produced or that there's a solid is produced, aka a precipitate, or water. Not sure how we're going to figure out if there's water or not, but we're going to see what ends up happening with these two guys, all right? So, in the meantime, copper chloride solution. Woo, hello. Woo, look at that. I don't know if you could see it. It's already fizzing. And I'm gonna get another one of my handy dandy little sticks. Whoa. Concentrations make a difference. A lot of times people are like, oh, it's rusting. It ain't rusting. I know, that was horrible grammar. Sorry to my language arts peeps. But it's not rusting. If you look at it, yes, it looks like rust. But what was in the solution? That's right, it was copper. What's the color of a copper penny? Oh, right, it's kind of like that reddish kind of look to it. Oh. The magnesium, the same thing. It's reacting and it's becoming coated with the copper. Now, the copper, when it's in the copper chloride solution, is just kind of like, I'm good, I'm chilling, I'm hanging with my peeps, because copper ion is not going to be created on copper. It's not going to replace itself. It's just going to be sitting there. All right. With this guy, it is slowly starting to react, but it's just not as concentrated as the other one. I should have made this solution sooner. Let's see, more copper. Now the thing is, copper sulfate doesn't dissociate in water as quickly as copper chloride, so it does take a little bit of time. I don't know if we really want to wait that long. It's kind of hot outside. So I'm going to speed up the process. And I'm going to add some chlorine ions to it in form of sodium chloride. I'm going to try to speed this little guy up. One nugget. Ooh. I don't know if you could see it on the camera, but all of a sudden I could see that the aluminum is starting to turn that little bit of red. Yeah, it looks more red. Definitely getting some more in there. The magnesium is taking a little bit longer for it to react, and that's okay. Yes, there's music playing in my head. But you know what, too? To me, this also shows why when you put the stainless steel scupula into the copper sulfate or the copper chloride, you don't necessarily see it happening right away, but it does happen. And then people are like, ew, I can't use this because now it looks all rusty. And it's not, it's just got all this copper on it. All right, so I got another trick for you guys, and it's about aluminum cans. So it's kind of a cool trick. I'll be right back. Ha! All right, so now I got myself a can. An ordinary can. So what if I could tell you that what I could do is that by, wait. I was going to try to rip it in half. All right, let me try it again. Let's see what happens. I just don't know my own strength, do I? Ha! All right, there had to be a trick to it, right? Yeah, there was. Obviously, the one that I threw away, that one was not treated first. This one was. So what's kind of cool is that I did do the single replacement reaction inside the can. Let me backtrack. If you think about it, soda has acid in it. A lot of phosphoric acid or carbonic acid, a lot of carbonic acid too, and it would just eat away at the aluminum. Because aluminum and acid, well, eventually over time, it will weaken and just snap in half. Not a good thing. So what they actually do is that they coat the inside. Thank you, Mr. Z, for taking off the top of this. There's a little plastic coating inside of it. All right? So there's a little plastic coating that keeps the acid from eating away at the aluminum. Now that I think about it, it's almost like how our stomachs are lined with certain buffers, but it's also got a protective lining around it because we have hydrochloric acid in our stomachs, and there's got to be something that's protecting it. Otherwise, it would eat it out. We would have no stomachs left. That's a tangent. Anyway, so what did I do? Glad you asked. I need a screwdriver. Flat-headed would work, all right? And you need volunteer of a can. And what you're gonna do is etch the inside of the can, kind of score it. Now, if I was in the lab, I would take my copper chloride solution and I would fill it up to the line that I made. Now, I don't know if you guys could actually see the line that I made in there, but to get it to go, because also I'm trying to conserve not just the chemicals, but trying not to have too much waste happening, is that I just poured a little bit. Again, it's not that very concentrated, it's just enough. And then I just let it soak and roll as it goes. Now you kind of know that something's happening. First of all, make sure you have your goggles on if you're going to start looking at this kind of stuff. But you could also hear that it's actually fizzing. It's almost going to sound like there's soda inside of here, but it's not. It's actually reacting. So the copper chloride is reacting with the aluminum to become aluminum chloride and copper. All right, so through the magic of television, say what? You're going to look for that copper that is going to be in there along all the scratches that you've made. And it's going to weaken it. And once you start to see the discoloration a little bit on the outside, that's when you want to stop, dump it out. You could dump it down the toilet. It's a root killer. It's not be enough that it's going to do that, but make sure it's down the toilet. When I read the instructions for the root killer, it's for the toilet, not for the sink, not for the tub. I think it's just for safety reasons. So it just weakens it just enough around that outside and where you can just rip it right apart. Ta-da! Thank you. Thank you. Thank you. Now that I did that experiment, I'm going to clear everything away. Okay, so we're going to try this with a can that Mr. Z graciously polished off all of the paint off of the bottom of the can so that it could be exposed, just the aluminum, no paint. I also have in here some hydrochloric acid. Please do not try this one at home. There could be a lot of fumes that come off of it, not too nice. So just leave it to the chem teachers to do this. So anyway, we're going to put this in and we're going to hopefully see the reaction happening. Hopefully kind of slowly, not too violently. And what we're trying to do is eat away through the layers of the aluminum to get to the plastic lining to prove that there is a lining that is there. I think I see some bubbles. Are there some bubbles forming? They are. Yay! thing. Oh man, you could actually tell that's plastic. I did it. It hurts to smile, by the way, with these things on. Wow, that's so cool. All right, guys, so that's it for this week. Enjoy the extra lines on my face, and we hope you enjoyed this week's experiments, and be safe, guys, and have a great day. Bye. Wear your safety goggles. I have spoken.
Hey everyone, it's Mr. Z here. It's the middle of the night, and I just woke up, and I thought, oh my gosh, we have all this double replacement, we have a lot of single replacement, we've done combustion, a little bit of decomp. What about poor old synthesis? So, I came out here, we're gonna do a synthesis reaction, and get eaten by bugs. So, I have with me some magnesium, which we're gonna mingle with some oxygen, and it's gonna create magnesium oxide. Now, synthesis reactions, elements love making bonds, and when it makes bonds, it releases energy, which in this case is gonna be at about, temperature is gonna reach about 3,100 degrees Celsius. And we get this bright white flame, which is pretty cool. They use these in the military to, if they have a bomb that fell that didn't explode, they will use this to get from the outside to the inside of that bomb so that they could take care of it. So yeah, it's very lightweight, but it packs a lot of punch if it catches fire, which is bad, if you don't mean for it to. So there we go. Now technically it also mingles with some nitrogen and becomes magnesium nitride, but it's mostly the oxygen that we're interested in. All right, let's see it. Nothing says party time like a blowtorch. Have a great summer, everyone.
Because I can't do like a mad scientist. That would have been a funny way. So what should we do? Because I was going to be like, I don't know what you could do with that. I don't know what kind of. I bet you that's going to be in the outtakes.